Yo, so this is what we're going to be making. When you click, you'll scan every grid block in the room for how many steps it takes to get there, and then it will search back to where the player is. And that way it can find the shortest path to the position. And it only scans as far as it needs to scan. And when you click a wall, it will just find the nearest free spot. That way, when you have a enemy try and follow you, it always pick the nearest free spot and it won't get stuck. This Pathfinder does seem to lag because it doesn't have heuristic data. But the closer the enemies are to you, the less it lags because it doesn't need to check as many steps. I've also made them move on a random cycle so that they all don't search at once. It's pretty simple once you make it work. I've made this template. It's got a sprite for the 32 by 32. We got an object for the path, the solid, and the map. We also got a room. We want this actually to be divisible by 32. So we want its size to probably be 44, because that will end up directly on 32 by 32. And we can start filling this room up with our solid object. I'll put it on the instance layer map. You just hold Alt and you should be able to click it all around. We're going to make another layer, which is going to be up for our path. We can just put the map in. The map's got the same collision as the grid size, so does the path. The path, we could actually make it a script so that everything can call it. But for now, we're going to make it obj path, and then we'll copy what the path system is into the script and then turn this into a player. So first thing is we need to divide the room into grids. Map is equal to ds grid create. And we need the width and height of the room. So the grid width is equal to the room width divided by the grid size. And the grid size is going to be 32 by 32. And we're going to do this for the height as well. So this map of the room is going to be with the grid width and the grid height. We only need to count this far, so we're going to cycle through the whole grid and check if there is a solid object. If there's a solid object, we're going to mark that grid location. So we do a for loop for the X. We're going to actually put that inside the Y. I'm going to put Y first. So now we've got a for loop that's cycling through the whole grid. And we're going to say that the map xx,y,y is equal to if there is a solid there. And we got to times this by the grid size. So now it's scanning through the whole grid and marking if there is a solid object there. And we can also have the map draw this information for us. So I'm going to copy this and have the map draw it for us. So as you can see, empty spaces are 0 and walls are 1. But we actually want them to be negative. That's all the map's going to do for us. And we're going to copy it over to our path script. So in the instance you create the path, it's going to copy the map. So now the path grid is equal to the map grid. And it needs a couple of variables. It needs where it's going to start and where it's going to end. So the start is going to be our location, and the end is going to be where we click. So the start is equal to x div the grid size, and the y is going to be the y div the grid size, and the x and y is going to be where we click. Now we're going to scan the whole map, finding how long it takes to get to each step. So we need to do a loop, but I'm just going to do a repeat 100 first, because I'm not sure where it needs to break yet. Okay, so we're going to set the start position to 1, where the player is, and we're going to count outwards from there, around all the walls, not going through the walls. So we set path to equal 1. And we also don't want it to be on a solid already. So we don't want to do this if it's a wall. Not equal to -1. Now, we need to count how many steps everything is away from the player. So we need to count. Count starts off as 1, because that's what we set here. So counting the steps all around the player, around the wall, we're going to repeat, and we're going to cycle every position. So this is using this for loop. I'm going to cycle every position. This is the maps variable. Oh, and that needs to be height. Let's fix that. And if that position is got the count, the step, then we're going to have to check all positions around it and add 1 if there isn't a wall. Yeah. And also, if there is no position that's equal to the step, then we can actually break the loop. So this can be while there is a count position. If it does find 1, it will just keep going. So we want to make sure that we're not going outside the bounds of our grid. So we go, if 1 step to the right is less than the width of the grid, so it's inside the bounds of the grid, and then we need to know if this is not a wall. If it's equal to 0, so it hasn't been set yet, then we can set this to equal the count. So we can go ahead and test this. Make something create the path. So let's make something that creates the path. Let's just go for the map for now. So this is just a temporary thing. Let's make the map, the path instance where our mouse is. I'm going to put it under the layer map on path. And go to. So now it should scan. We want it to draw the path. So we're going to stop the map from drawing the solids. We want the path to draw its path. So we'll go the path grid now. And it can't be a temporary variable in that case. This is the maps variables. So as you can see, it will check all the positions to the right up until the wall. You want to check all 4 directions. So to the right and then to the left, we want to make sure that is greater or equal to 0. And we can just go take one. And then this is the vertical. We can make sure it's less than the height of the grid. And go +1, +1. And we want the y to be greater or equal to 0. Y take 1 greater. And then take 1, take 1. Now we're doing all 4 directions. Now it's cleaned up. We need to actually put the count in just at the bottom of the loop. Is by counting back from the end position and following the shortest numbers back to their route. So to find the path back, we will put all the steps into a list of the X and Y positions. So the steps is the amount of steps it takes to get to the position, and we'd count upwards as we fill the list. So the first step, position 0 of the X coordinate, start X and start Y. The path X is, actually these are the ends, so the end X and end Y. So therefore the first position is actually the end, which is path X and path Y. But we also want it to be in the middle of the square. So this is going to be equal to grid size over 2. It's also going to be multiplied by the grid size. And we don't want steps to be a temporary variable. We want these to be remembered and find the shortest path. So we're just going to repeat this because I'm not sure how long it repeats for. It actually repeats until we found the very first number, which is 1. So to check which number is less, there's never going to be more than 1,000 steps. So we check to begin with, and we're going to do this until, well, we're going to repeat this while the number result is less than 1, because when the number result is 1, that means we're at the start again. We check the position next to the end for this and get the resulting smallest number, and we take a step in that direction. If it's in the bounds of the grid, we get the number. So number is equal to the path x plus 1, path y. So that number, we got to check if it's the smallest number out of all the squares it's looking at. So if the number is less than the number result, then it's the smallest square out of all of them. We say the side is equal to 0 for the right. There will always be a side. The side is equal to -1. To begin with. So side 0 is the smallest resulting number, and we want to update the number to be the smallest side. So that's how you check to the right if it's the smallest number, and we're going to check to the left now. So if say it's inside the bounds of the grid, then we say take 1, and then if it's to the left, it's side number 2, and to the bottom, inside the grid, the side is 1, and upwards is three. So now we're going to check all the sides and move a step in that direction. So if the side was equal to 0 to the right, then path x is 1. Else if side is equal to 1, which is down, then you get the idea. We move it in the direction that the side is. So if the side is 2, which is to the left, we take 1, and if side's up 3, then we take 1 from the y. And then now that we've moved it all, we've got to add the step. So we say step 1, and we tell the step position in the list to be equal to where the path is now. In order to draw these steps, we go to path, and we say, we'll just, that's the number of steps to get to a position, but we want to draw the steps. So I'm going to copy a variable. So after this whole thing, we're going to say that the maximum number of steps is equal to steps. Let's change this to steps. Yeah. Okay, the step max is equal to the number of steps we've taken. So now we know the total amount of steps. We can go in reverse, because you need to reverse the steps, because it's stepping away from the final position. It's equal to steps max. And if there's more than 0 steps. So a line takes 2 positions. We need the previous position, then the next position. So we're going to make some variables. So the previous step is equal to the steps in the x direction, the first number of the list, so 0, and and the y step is also 0. Oh, it's actually steps max. And then we'll take 1 from draw steps, and then if it's still, so it can't be equal to 0 because it takes 1. And then if it's still over 0, then we can start drawing it. We can say to draw the line, which is from step x, 4 steps, so where it's going to from where it was, which was previous step. Then we can say minus a step, and as these steps get smaller, we need to reverse it. So steps max take, steps max take. So now it's reversing through it, and we want to set this again. So the previous one is what it's currently, which is these ones. We're going to make this steps, and we're just going to make this easier with draw step x being that. Oh, this needs to be a while loop. And this needs to be equal to the steps max minus draw steps. Now we want the path object to be somewhere in the room, so we'll put him here, and so instead of creating him, he's already created, so we can delete that one. And then instead of create, this can be called every time that they click the left mouse. So we'll make it as a script. And now when you click, then it's going to call this script. Let's create them here. Steps and steps max are what the path script creates. There you go. So now it's finding the quickest path, but it's not including diagonals. So we can use diagonals. We can implement diagonals by doing another side check. And also it can only be one step away from another side already checked. That way it doesn't diagonal through walls. So it's going to be, the first one is going to be the top right. The first diagonal is going to be the top left. So that, and we're also going to check the Y position. So we check this one. To the top left position of the path is within bounds, and it's going to result inside 4. And it can only be one step away from any other position. So the number minus number result should only equal 1 step. It can be a whole number if we do this. So it's 1 step away from left, right, up, or down. And it equals side 4. So if we did that here, would that say also path x equals 1? So we need to do this for all 4 diagonals. So the top right is path x plus 1 and side 5. And it needs to be less than the grid height, width. Now that results in 5. Now we want 6 and 7. So 6, 7. 5, 6, 7. So it's going to go top left, top right, bottom right, bottom left. And that's 1, 2, 3, 4, 5, 6, 7. Okay. So where are we up to? We've done this one and this one, which is top right. Now, bottom right is both positive. So we'll copy this one. And we'll check it against this one. We'll check if it's in the bounds on the Y. It's less than the height. And that results in 6. And then if the bottom left, so take 1 plus 1. If the pathway is plus 1. Yeah, bottom left. Okay, so let's just check this. So to the left and to the up. Yep. To the right and to the up. Yeah. To the right and down. Yeah. And to the left to the down. Yep. So that's up, right, down, down, left. Okay, so now it should pick diagonals. Like so. And there you have it. You have a diagonal Pathfinder. And you can't click through walls like that. See, that's what the one step is. So every time you call a script, it's going to save your steps, and you can take one step away every time your player moves through this list of X and Y coordinates. And we're just going to draw this, but we're only going to do that if there's already some steps, which is checked here. So now you can see all the steps it's checking. And now a performance upgrade we can do. We can say once it's marked the position that it needs to be, then we can break the loop. So if the position that we need to be is already marked, so it's not a free spot anymore, then we can break the loop. See, now it's only searching as far as it needs to search, which is going to be the number of steps away. With heuristic data, you can check only the direction you're moving. You can set this to the path of path X and path Y. And you don't need to create that just yet. So now when there's no result, it's got no path. And there you go. Now I'll just show you what I've done to trace back through the steps in my player object. This is how it goes through the steps. It moves at a set speed. If it's a shorter distance than the set speed, then it does the shorter distance, and then the remainder of that is used to get to the next step. So that's how it's all smooth. And only pick a new path if it's currently on a fresh step. That way, when you click to move to a new position, it doesn't go to a whole position to begin with. It just goes when it is on that whole position. Otherwise, yeah, just stop moving. So that's how the player moves. It's also doing the reverse on the steps. For being able to click on a solid wall, I've made it so that instead of just calling path, I call a spiral first. So the spiral is going to check the nearest free position, and then it's going to use that as the path and location, and only if it's inside the room. And this is the script for the nearest free position. Basically, so this is for the nearest free position. So it has a count. It goes 1, it moves to the right 1, and then it moves down 2, and it moves left 3, moves up 4, and that way it checks all the nearest free positions. Just repeats that in a spiral. So that's where these states come in. And I'll show you that in action. You can click on a solid object. This is what it looks like without the numbers. You can see it moves very quickly and fluid between each step because of the remainder move speed is added to the next step, and it will find all the way. The game doesn't lag as badly when the enemies are close together. I've seemed to get away with probably 12 of them. And also this grid is quite big, so I would say it's a big room. You could probably zoom right into the character, and then that way you get a lot more performance out of the grid Pathfinder.